in the last video we have discussed about what? We have discussed about reflection of light and laws of reflection. Today class highlights, you see the class highlights. Number 1 is what are spherical mirrors. First, second is terminology, that means different terms involved in case of spherical mirrors. And third one is what? The relation between F and R. Here F is the focal length of the spherical mirror, while R is what? Its radius of curvature. So first we have to know what is a spherical mirror. Okay, there are two kinds of spherical mirrors. One is this and the second one is this. This type of spherical mirror is called concave mirror. Okay, and this kind is called convex mirror. Convex mirror. So there are two kinds of spherical mirrors, concave mirror and convex mirror. Okay, suppose this mirror is XY, this is suppose XY. If you complete, that means if you complete this surface, if you complete this surface, it makes a what? Sphere. And the center of this sphere, for which the mirror is a part, is called the center of curvature of the mirror. So what is center of curvature? This is a terminology. What is center of curvature? A spherical mirror is a part of a sphere, and the center of the sphere for which the mirror is a part is called what? The center of curvature of the mirror. Now if you draw a straight line passing through what? The center of curvature and passing through what? The midpoint of the mirror is called the principal axis. This is called principal axis. So what is principal axis? It is again a terminology. What is principal axis? A straight line passing through center of curvature and the midpoint of the spherical mirror, which is called pole. Midpoint of the spherical mirror is called pole, and the straight line passing through what? The center of curvature and the pole of the mirror is called a principal axis. So what is pole? Pole is the what? Midpoint of a spherical mirror. In case of convex mirror, you see this is the pole. If you complete a convex mirror like this, it makes a sphere. Center of the sphere is called what? The center of curvature of the mirror. Now if you join C and P by a straight line, then this is the principal axis. Okay, now suppose a ray of light is incident on the spherical mirror. After reflection, this ray is strictly parallel to principal axis. You see, this ray is strictly parallel to principal axis. So a ray coming parallel to principal axis, after reflection from the mirror, passes to the focus of what? The mirror. So what is principal focus? When a straight line, that means when a ray of light is incident on the mirror and the ray is parallel to principal axis, after reflection from the mirror, it passes through a point of the what? Principal axis, and that point of the principal axis is called the principal focus. Okay, now all distances should be measured from what? Pole of the mirror. All distances should be measured from what? Pole of the mirror. Distance of focus from the pole is called focal length and is denoted by F. So what is F? F is the focal length and it is the distance of a principal focus from the pole of the mirror. And the distance of the center of curvature from the pole is denoted by R and is called what? The radius of curvature. So what is radius of curvature of a mirror? Distance of center of curvature from the pole is called radius of curvature, and distance of principal focus from the pole is called focal length. Now in today's class we have to find a relation between what? The focal length and radius of curvature of a spherical mirror. Okay, so go for the main topic of this class, relation between F and R. Relation between F and R. Suppose this is a concave spherical mirror. Suppose XY is a concave spherical mirror. Now first draw the principal axis. What is principal axis? The straight line connecting center of curvature of the mirror and the pole of the mirror is called a principal axis. Okay, suppose a ray is incident on the mirror which is parallel to what? The principal axis. A ray coming parallel to principal axis is incident on the mirror. After reflection, when it gets reflected, then it passes through what? The principal focus of the mirror. Okay, so this is the reflected ray, this is incident ray. After reflection, it must pass through principal focus because the incident ray is parallel to principal axis. Distance should be measured from pole of the mirror. So distance of focus from pole is focal length, and distance of center curvature from the pole is what? The radius of curvature. Now we have to find a relation between F and R. Now suppose this point is K, this is S, light is coming from source, and the point of incidence is suppose K. Now join C with K, join C with K. S, C is the center of the mirror, C is the center of curvature of the mirror. So this is a, what? Radius. Radius always makes an angle of 90 degree to the sphere, you know. That is why this is the normal at the point K. Angle between incident ray and normal is called angle of incidence. Angle between reflected ray and the what? The normal is called the angle of reflection. Okay, and all we know, I equal to R in case of reflection, angle of incidence equal to angle of reflection. This is angle of incidence because this is incident ray, this is normal. This is angle of reflection because this is reflected ray, this is normal. Okay, and according to the principle of reflection, I is equal to R. Again you see, if this angle is I, this angle is also I, because alternate angle is or not. If this angle is I, this angle must be I, alternate angle, you see. Okay, so suppose this is figure number 2. Okay, in the last class we have drawn a figure that is noted as figure number 1. Suppose this is figure number 2. Okay, now you see in the triangle, CKF, in the triangle CKF, this you see, this is the triangle CKF, angle KCF equal to angle CKF, is it not? Angle KCF equal to angle CKF, because I equal to R by the law of reflection. Is it not? According to law of reflection, what? I equal to R. This angle is I, this angle is again I, you see, alternate angle. Okay, if I equal to R, then in the triangle CKF, I equal to R means what? Angle KCF equal to angle CKF. If angle KCF equal to angle CKF, then so we can write it like this: the FC is equal to what? KF. Is it not? In case of a triangle, if these two angles are equal, then side FC must be equal to KF. So FC equal to KF. Okay. Now is it visible? Is it? Now as K is close to P. Let us suppose that K point is very close to P. Suppose K point is very close to P. If K is very close to P, then PF equal to KF. Then PF on an approximation is equal to what? KF. Am I right? If K is close to P, then distance between P and F and distance between K and F is approximately equal. Okay, so you can take it as PF equal to KF because K is suppose very close to P. Okay, now what is PC equal to? PC equal to what? PF plus FC. Am I right? PC equal to PF plus FC. Is it? Now this is PF. PF means what? KF. PF means KF. PF is equal to what? KF. Okay. Now in place of PF you can write KF. Am I right? PF equal to KF. So in place of PF you can write KF plus FC. But what is KF equal to? KF equal to FC, isn't it? So in place of KF you can write FC plus FC because KF equal to FC. Now FC plus FC twice FC, so PC equal to twice FC. Am I right? Now what is PC equal to? PC means distance of center of curvature from pole, so it is R. Distance of focus from pole is F. So in place of PC you can write R, in place of FC you can write F. Well, that is f equal to what? So f equal to r by 2. Is it? This is the relation between what? Focal length and radius of curvature of a spherical mirror. That means focus is at the midpoint between what? Pole and radius of curvature of a mirror. That is why f is equal to what? R by 2. That means focus is always at mid between what? P and C. So for any kind of spherical mirrors, whether it is a concave mirror or a convex mirror, the focal length is half of the radius of curvature. As for example, suppose if you take, for example, if radius of curvature of a spherical mirror is 20 centimeter, then what is the focal length of the mirror? Then focal length is r by 2, so it should be what? 10 centimeter. Clear? Next, now in this video we have to know one more thing. What is this? Be focused. This is what? A concave mirror, am I right? This is what? A convex mirror. In case of concave mirror, the center of curvature and focus and center of curvature are at the left of, that means in front of the mirror. In case of convex mirror, center of curvature, because here is this, so center of curvature and focus both are behind the mirror. That is why focal length and radius of curvature both in case of convex mirror are positive. In case of concave mirror, as focus and center of curvature are in front of the mirror, not behind the mirror, that is why the focal length and radius of curvature are negative. Okay, so focal length and radius of curvature for a concave lens are taken as negative, while focal length and radius of curvature for a convex mirror are taken as what? Positive. Focal length and radius of curvature for a concave mirror are taken as negative, while focal length and radius of curvature for a convex mirror are taken as positive. Okay.